of classes here is going to be very small. So let's actually start diagramming this. We're just going to do a skeleton today because I know I'm going to have main. I don't even know if I care about, right? I don't know if I care about main at all, but maybe I do. So we have the game, we have a player, right? I have the linked list. So this is going to be a circular linked list, right? That is going to be generic. If you want to be really complete, we were talking about earlier based on somebody's question. Let me make sure I'm not blocking it for the video people. If you want to be really complete, you could bring out the node class as we talked about, right? You could bring this node class out and you can have a depends on relationship between this and this. If you want to be really complete, you can also bring out the iterator class, which might be called circular linked list iterator, right? That's going to also be a generic, and this is going to be a depends on relationship. If you wanted to be super, super complete, you would also have an interface, right? An interface declaration here, come on. And that would be iterator, right? This is going to be interface, iterator, E, right? And this list iterator is going to implement this interface. Now, so if you really want to be super complete, and then again, this depends on arrow, I would point it to itself, right? So, but this is just really being extra complete so that when you look back at this project, you understand what you did and why, right? But this is just sort of, filling out all of the details here, okay? Otherwise, you have game, you have player, and then I have a main that's sort of uninteresting, mostly uninteresting, okay? And main is really just kicking things off. And main, in fact, is going to have a dependency on game. Game's going to have a dependency on player. Game's going to have a dependency on the circular linked list, okay? Main is really just kicking things off and giving it the parameters of the game. You can imagine main being replaced by a GUI, right? A graphical user interface where they get to select how many players you want. Do you want these players to be automatically named, or do you want to supply a list of players? How many strikes do they get, right? So the game is going to sort of, the main is just going to supply hard-coded values for now, but you can imagine easily having some nice shiny graphical user interface to kick the thing off in another day. Notice also we're only playing one game. We're not having a scenario where it says, do you want to play again? Because the way you construct it is going to be a little bit different. If you want to do that scenario, you have to think a little differently. So I would get the project working with the expectation that you're going to have one iteration. You're going to play one game and then you're done. Okay, and then after you get that done, if you want to play, you can dive in a little bit more. Okay. Make sense? I'm not going to give you everything because you can certainly go do the rest, but this is a good start. I'm telling you that I don't have very many methods in any of these classes, right? Player has a handful of things that are very simple. Game, I think I have 3 or 4 methods, but it's mostly just one thing, and that's play, right? So I know that I'm going to have a constructor here. You got to be able to kick it off here. So I know I'm going to have a game constructor. It has some stuff in it, right? Because the game constructor is going to say, I need to be told how many players and how many this and how many that. And then I know I'm going to have a play method, right? But there are really not a lot of methods there. All of my logic is here. If you want to make helper methods, you certainly can, but there's really not a lot of stuff here. And I'll give you one for free that you should be able to tell me, what is the key attribute? What's the key data that the game is going to have to make this thing go, given the rest of the model?
A circular linked list.
That's right. It's gonna have all those. It's gonna store that data, right? So yeah, all that stuff. But the thing that we're certainly going to need is a thing called players, right? And that is going to be a circular linked list of players, right? And yes, you're going to have. I'm not giving you complete anythings here, right? I'm just giving you the barest hints to get you going. But what I'm telling you is none of this is very big or exciting. Right? I mean, literally, these classes are small. the circular linked list, you may do whatever you like with this if you want to be complete, but I wrote the methods that I needed for the game. Right, so I did not try to make this complete. I did not try to add everything in the world that I might add. So I tried to do the stuff that I really needed to do. And that's going to be something like, I got to be able to know the size. We talked about why, right? I have to be able to add to this list, right? I might have a couple other little helpers I need to be able to remove, right? Because I got to kick players out. So really that in the iterator, I mean, there's literally just a few methods in there. Okay, just what you need. You don't need to add any fancy stuff in here. So add, remove, size. There might be a get, some sort of get thing that might be interesting. Remove the iterator. That's about it. Okay. So none of these things have a whole bunch of anythings, right? It's just not that deep in terms of each one. So where's the work here, right? Where's the work? Are we hiding the work? Well, the circular linked list actually does a lot of the work for us. If you get that working properly, and I mean tested and working properly, right? Remove is a landmine if you're not careful, right? The iterator is interesting here. So you got to really think about the iterator. And again, you know, we're building this stuff. It's our playground. So when I was thinking about this thing, I thought, you know what? The typical iterator will hand you the items one by one and then stop when it's at the end of the list. But I thought, you know what? What should a circular linked list's iterator be? Should it be the same? Should it hand me one item and then stop when it gets to the end? And I thought, you know what? I don't think so. In my circular linked list, I think the iterator should keep going. If the list keeps going, why doesn't my iterator just keep going, right? So when I implemented the iterator, and I suggest you do the same, make your iterator just say, yeah, as long as I got stuff in the list, I'll give you the next one, right? Has next will always succeed as long as I've got an element, right? And I'll just give you the next one. So I think it's fun to play with this idea and say, you know, I know maybe a typical iterator does X thing, but in this world, what does it mean? If we want to bend the rules a little bit, it's our stuff, right? It's our stuff. So I think that's kind of a cool idea that the iterator is a little different than a standard one, that it just keeps giving you stuff, right? It doesn't stop. Okay, so that's just kind of fun. It's, again, it's our playground, so we'll play, right? Does that make sense? So main is going to just throw in some hard-coded data, 4 players, you know, the sleep time, in other words, how long between times, because while you're testing, you don't want to watch a game that goes really, really slow, right? It starts driving you crazy. You want a game to play very fast. So a main's going to ask, have those hard-coded things like I want 4 players, I want a quarter of a second between rolls, I want 3 strikes per player or 5 strikes per player. So it's going to ask all those questions, and then it's going to pass that into the game constructor, and then main is going to say play, like go. And then the play method is really where the work is. So the 2 places where work lives in this project, the first one is the circular linked list itself. It doesn't have a relationship with anything else. You're going to take the code that we wrote last time or your own linked list code, and you're going to adapt it here. I, again, highly recommend that you go write the iterator. You'll really understand iterators better. Go look at the array list one, figure out how it does its thing, figure out how that's going to be adapted and work differently in this world, right? Great experience if you just write this stuff rather than trying to look it up somewhere, okay? So part of the work, the first part of the work is in circular linked list and the testing of that. The other part of the work is in the game logic, right? It's in the game logic. And for that, I've told you how the game plays. I'm going to show you how the game plays, but that game logic, you just have to think about, right? But it's basically a dice rolling sort of game. And the idea is every player rolls the dice, right, that can add up to 100. Right? So you can end up with a roll of anywhere between 1 and 100. The idea is whoever has the highest roll is in the lead. And if somebody else ties that roll or exceeds that roll, they take the lead, and then so forth and so on until you eliminate all the players because they strike out and then get eliminated, and then the last person standing is the winner. Make sense? Right. games are no fun unless they have sounds. We're not making it pretty and animated and colorful, but games are no fun unless they do something more active, and sounds as extra credit, actually not very hard to do, but they really add value to the game playing experience. Yeah, Blake, go ahead.
I noticed in the sample playthrough that one of the players got to 100. What happens when a player ties with 100?
They would take over the lead, and the other player that had rolled it before would be forced to roll again, but nobody would probably be able to statistically beat it.
Gotcha.
So it's high or tie. So if you tie the previous roll, previous high, you take over the lead, and then the next time around, they have to roll again, right? But in a given round, if you have the lead already, you don't have to roll. Like if you're already in the lead, you're not forced to roll. You just sit back, right? But if you tie the previous high, then you become the leader. Does that make sense? This is a particularly interesting game, and I played a whole bunch of them, but I really like this one because you'll notice here, this was like, what did I do here? This must have been, yeah, so many, yeah, I don't remember how many strikes. We must have had 5 strikes, yeah. So notice here in this first round, somebody ended up rolling a 59. So player 1 was in the lead, but player 1 didn't have to roll again. But in this case, then somebody rolled a higher number. So when it came back around, player 1 had to roll again. So, but now player 1's in the lead with 96, right? So we go through 96, so 96. So here again, player 1 sitting at a 96, so they don't have to roll. So we kept going here. We're at 96, 96, and then notice player 5 rolls a 98. So now player 5 takes over the lead, and then we keep rolling, rolling, rolling. Now player 1 gets a strike because no longer in the lead. This player is struck out because they got too many strikes. And then we got lucky here with player 2 rolling 100. And then nobody bested that. Nobody else rolled equivalent to that or more. So eventually player 2 won because of this one lucky roll right here. Okay. Does that make sense? Blake, is that a leftover hand or a new hand?
Sorry, that's leftover.
Okay. No problem. Just wondering. Just want to make sure. Okay. So you want to see how it looks. It doesn't have a fancy UI, right? Mine, but if you have your volume up, you'll hear my